Hello everybody, wherever you may be around the world, I'd just like to welcome you to this afternoon's webinar on ProtaStructure 2019 with a little bit of insight into what we've been doing with development recently with the imminent release of Service Pack 7. My name is Nigel Watts and I'm the Managing Director for ProtaStructure. I'm based out of Kuala Lumpur in Malaysia. And I head up our team in Asia, and obviously we also have a very large team in Europe and in Turkey that support our user base. I really appreciate everybody's attendance today. Obviously I know that the situations are quite trying with what's happening globally, and I hope that during the course of this session we can just provide a little bit of insight into what we're up to, maybe take you away from a bit of the boredom with being at home or isolated wherever you may be, and update you with some of the new technology that we've been working on. So I'm just going to sort of start briefly with looking at Prota's our organisation and give you some background on what we do. I'm then just going to briefly give you an overview of the software and how this fits together, so you have some insight into the various components that make up ProtaStructure. And then I'm going to show you live software. I'm just going to dive straight in and talk about how the system works. And I'm also, for those existing users in particular, you're probably going to be keen to know what we've been working on over the last 3 or 4 months. So I'm going to update you with some of the new functionality that we've been introducing to the system over the last recent while. Now, just some background into ProtaStructure. We've been around since 1985. We are a global company, really with a real focus on software development, engineering, and consultancy. Okay. Sorry, I'm getting a few messages here. Just let me say. We've got a team of people. Here's some of the guys. We're all busy working at home. We'd also like you to stay at home if you can. We would like you to stay safe and be able to continue using our products, continue to take advantage of things when things eventually settle down. Okay, so what I was going to talk about with Prota is we've been around for many years. We were established in 1985. We're actually part of a group of businesses. So the software is one thing that we do, but we're also part of a bigger organisation which deal with engineering, architecture. We also get involved with other software products. We're a very large Autodesk reseller, and we have other entities around the world that we've been setting up. Now, the journey on Prota started back in 1985, as I mentioned, and there's been a lot of interesting milestones along the way. I think probably the most recent milestones would be the introduction of what is now our ProtaStructure system, which was introduced in 2015. This brings together some of the latest technology that we've been working on to really enhance the way in which we deliver software solutions and help you deliver projects globally. Presently, we have a team of over 350 staff, mainly practicing engineers and architects. We also work with a number of partners in various countries around the world, and we have thousands, literally thousands and thousands of people who are using our systems every day to deliver their projects. Now, we take a very keen interest in design and in engineering, and to help continue to explore and continue to develop the solutions. We get involved actively in research. We've published a number of papers that are available on our website, particularly in the fields of seismic engineering. We're doing a lot of research in these areas, and we're feeding that research and development into the software as well. So we're headquartered in Ankara in Turkey, but we have a global setup, and we're expanding our reach. We actively work with many partners around the world as well um, to bring solutions, and this is growing across Europe, into Africa. I'm based in Asia, and we're making so we're growing significantly across the Southeast Asia, Asia Pacific region, and we're also starting to move into the Americas. So it's a very exciting time for our business as we continue to invest and grow our development. Now, the engineering side of our business is it's a really interesting business. We've been involved with designing and delivering some very unique projects over many years, and this has really helped shape the software and what we do within the products. So we've been involved with delivering some very large industrial, commercial, civil, infrastructural projects using our systems. We've been involved with delivering things like the Istanbul Metro. Last year we were involved with the largest terminal building in the world. We were involved with full design services for this. We've also delivered other interesting projects, number of airports around the world, Cairo Airport, St. Petersburg, Pristina. In fact, we've designed over 20 airports globally. We've also been involved with some very large, quite complex and challenging educational facilities and medical facilities. Recently, we were involved with the largest hospital in Istanbul, and we've also delivered on a range of other interesting projects. An interesting one we've just been involved with recently was the new Turkcell building. This was for a data center for mobile communications, which houses very sensitive equipment. And part of the design process was looking at how we could ensure that the building was functional after an earthquake, and that sensitive equipment was protected. So there's a lot of interesting parallels with what we're doing in practice as a consulting firm, and bringing that experience into shaping and delivering the software. Obviously, we also work very closely with our clients to ensure that that the kind of development that we introduce is fit for purpose. So today I was going to talk about ProtaStructure 2019, and in particular Service Pack 7. ProtaStructure is actually a collection of tools that forms one complete integrated system. Now, everything comes together, so it is one package. And the concept behind ProtaStructure is it's made up of a central modeling platform, which is ProtaStructure, and it has ProtaDetails and ProtaSteel for concrete and steel detailing. And being a physical modeling system, we can integrate this with other platforms, including Revit and the like. So just a bit more detail on that. So ProtaStructure is a structural BIM design solution for concrete and steel buildings. Now, what do we mean by that? Well, we are working with physical objects to develop models very quickly. And as we develop the model, we will automate a lot of the things that you would normally do conventionally. Things like loading is automated. The underlying analysis model is automatically generated, and we proceed to prepare and carry out all the detailed design, right from the roof right down to the foundations. And we cover a broad range of different codes of practice to do that. Now, we will provide you with full design reporting. All the calculations will be produced, but we link out to our other platforms, ProtaDetails and ProtaSteel, for helping you create your drawings in an automated fashion. Now, our users tell us that they like this system because it's easy to use. It's very, very logical and intuitive, as you'll see, and it also helps them deliver projects faster and more efficiently than they can using conventional means. Now, ProtaDetails, after you've designed it, it automatically then moves in and from ProtaStructure and creates all your drawings in one click. So it'll arrange things into your sheets. It is a complete CAD system, so you can make changes in here, and you can just adapt things to suit the end product. Okay, it works natively in DWG, So it's very much a little bit like AutoCAD in the environment, and you can use it as your own preferred drafting platform if you wish, but we've got specific tools in here that help manage the delivery. And also we have ProtaSteel, and ProtaSteel allows you to automate all your connection design, and then from there you can produce all your detailed drawings right down to shop detailing. Now BIM's becoming increasingly important with how our clients deliver projects and communicate with other project parties. And this is why we've spent significant time investing in integrating and having an open platform where we can share and communicate with other platforms which are commonly used in the engineering and architectural space. So we have bidirectional links with programs like Revit. We have links out to IFCs. We have direct links into other platforms like ArchiCAD and Tekla. There's a range of tools here that just allow you to easily take information out and share and communicate with other people within your project team. Now, the links are intelligent. You can work in a bidirectional manner. You can make changes, say inside Revit, and those changes can be communicated back into ProtaStructure. So the whole idea is that working with a physical model, these processes become very easy and very seamless. So enough of me talking and introducing us. Let me get into the software and show you how this works. So I'm just launching ProtaStructure, the 2019 version, and when we start the system, just give it a second, it's going to load, and you'll see it's just flashing up. I'm using SP7. We're about to release this into the market. It's a small update that fixes a number of known issues that we've had, but it also enhances significantly our OpenSeas integration. Okay. Now, when we do, if you're new to the platform, we have quick start guides. We've got online help systems, YouTube type videos that you can watch. You can also, we also regularly update the software, and they're all fully documented, so you can see what's new progressively as we've rolled out new service packs. And what we tend to do nowadays with new development is we're continually rolling out new features and functionality, as well as updates to the system, in between us having major releases. Now I'm just going to come in and create a new project. You can give this project a name. Let's just call it Global Prota. And if you hit OK, you're then faced with a series of templates here. Now these templates will help drive your design and detailing. And you can come and choose any template you like in here, depending on your location. Now we've studied different markets, and these templates have been set up to suit local practice in each of these markets. So if you're doing a project in the UK, you could load the Eurocode template there and follow local practice in the UK. Maybe you're doing a project in Singapore, or perhaps you've got a project in Ireland, or maybe even Hong Kong. So you can just come and choose these templates, and we've then locally customized those to suit the way which engineers would typically work within those countries. Now I'm going to grab a Eurocode template. I might work with a Malaysian template here, and I'm just going to import this, and then this will then set up things to suit the Eurocode. Okay. Now, when we start any project or move into the environment, we can start in different ways. So you have, you can, if you wish, bring in information from an architectural plan. You can import from Revit physical information. If you're working on big projects, you can actually split the models down. So somebody may be doing a podium, somebody's doing a tower. You can actually combine projects together, and you can have 2 or 3 people working concurrently on a project, and these can then be combined. Now, if you look at the modeling environment, we've tried to make this very simple and clear and easy to follow. So you work your way from left to right. Initially, you might start with creating grid lines and objects, and then you move through to analysis and design. Now I'm going to build a simple model here. I'm going to try and do 2 things as we go. So firstly, I'm going to try and introduce ProtaStructure to those who perhaps have not seen the system before. And I'm also going to try and refresh some things in the minds of our existing users. I know there are many listening today, so I'm hoping to also just give you some insight into the product, and maybe give you some background that you maybe don't otherwise already know. So when you start, you could import from a DXF file, but I'm just going to create a simple geometry here because I want to just take you through the basic modeling process and just touch on that. You can key in some grid lines here to help set things up. Once you've got the grid lines in, these are actually dynamic, so you can work with these, okay, and you'll see that you've got properties dialogues that get set up with a grid line. You can select the grid line and then you can start to make changes to it. So if I decided that this particular axis, I don't want this to be straight, but maybe I'd like it, define it as a curve. So in here, you can come in and set these up and create. Now you're not constrained, so if you have a very irregular geometry, maybe here I've got an axis which is not exactly straight, you can come in and create these in here. So I can just use this to help me create any unusual geometry that we've got, and you can create, here you can see you can virtually create any type of grid line arrangement that you like. Okay. Now we use the grid line arrangements to help us set out. Now at this point in time, I might want to come in and place some columns. Now you can see that the object that you're working with is previewed, and you can then click to create that in the model. Okay, and you'll see that as we're going, we're automatically creating numbering and labeling for the elements in here. To create multiple elements, you can box around. If you wish to change the orientation of things, you can type in different parameters here. Okay, maybe I've got a column that's, maybe I want to orientate them along the curvature of that grid. You can see that I've just automatically aligned those there as I've gone. Now in the library here, we've got different objects that you can work with. So I'm using maybe some concrete elements here, but I could very well be working with steel. Okay, and there's a range of different steel libraries that you can draw from. You can create your own sections, built up sections in here. There's also cold form and composite elements that you can work with here. So you can just draw from this library and choose the elements that you want to work with, and then go away and create those in the model. So if I create a 500 diameter column here, we calculate the underlying engineering properties, and then you can then go and grab that and use that in your model to create. So here I'm just placing some additional columns in my model. Okay. At the same time, I may also want to place my core wall. So again, I can just key the core wall properties in the dialog, and then I can go about modeling that. Now I'm going to move to beams, and in here you can key in your beam properties. Okay, you can control things like fixities and alignments and so on here as well. But to create your beams, you can just box around to put them in. Okay, and you can see I've just quickly boxed around, or you can click between elements. Now, if you have unusual arrangements like here, I might have a beam that's cranking, it will just follow that grid line, or I can just snap to a column and then that is created automatically. If I have a beam that's, say, curved, we can just instantly come and create that curve as we go. Now, if you have lots of members, you can just box around to put those in, okay? And the system will automatically create those members. It hasn't split these beams. If you have beams which are, maybe I want to place a beam through this wall, we understand that those beams and walls are already existing. You don't need to worry about overlapping. You can just draw them in, and we'll create those extra members either side of those existing elements. Now I'm going to snap to some points here. I'm going to snap to, say, mid-span. You can see there's some handy snap points that we can use just to create those in. And you can come in and maybe you want to change the beam sizes and so on as you go. But if you've got a particular distance, and if you hit F2, you can just type that in, and you can just place. Whoops, sorry, let me do that again. Okay, so as I'm mousing over, maybe I want to place a beam at a different point. You can just select those points, and then you can place them in. Now in here, once you've got the geometry in, you can work with this. So you can see that I'm just using my cursor keys to move these around. If I hit Control, I can move them back and forward. So I can just reposition the geometry to suit the underlying architecture. And that could be for a beam, or it might be for some columns as well. So I can just move these into place and adjust them to suit the underlying architecture. So the idea here is you don't need to be perfect with your grid line set out. You can just adjust and tweak things to suit. And what you might also see here is that this is starting to look a little bit like a key plan. Okay, now I'm going to come in and key in some dimensions here. I've got maybe a 200 thick slab. Okay, I can draw from a library of finishes, and you can build up finishes with things like screed and marble and so on to create finishes. And you can also, if you're not sure about live loading, this will connect to the code, so you can just come and choose what might be appropriate for your building. So maybe I've got a bedroom and that's my finish, okay, and then I can just click and we can create those elements within the model, okay. I may want to type in my own values. You're free to do this, okay. Maybe I've got a toilet area where the live loading is a little bit higher. Again, I can just come and define this in the model here, okay. If I want to just key in my own values, any of these can be just adapted to suit, okay. So you can just happily go around creating these within the model, okay. Let's just do a couple more, and maybe I'll make that, I don't know, maybe it's 0.7, okay. Now, at this point, before you get too far, you may want to come in and review what you've done before you actually develop the model upwards. So in here we have tools for just interrogating the model, making sure that we are happy with what we've created. So here you can see the different column sections that have been used, or maybe different beam sizes that we've employed within the modeling. I may also want to be looking at what kind of superimposed dead loads I've placed on the model, or maybe what live loads. So all of this is interactive, and you can see and check the model before you get too far. So that's a great tool just for being able to check before you start to develop things upwards. Now, there's other things you can do in here. We have things like adaptive sketch lines. So if you've got unusual geometry, maybe over here I've got a slab which is a bit different. You can come in and just come in and use these sketch lines to create maybe the geometry of a slab, and then I can come in and place that within the model. So it could be a 150 slab. I can choose the type of slab it might be here, okay, and then maybe I want to drop it 100, for example, and then we can use it as a boundary to help us create that element within the model. Now, I've been working in a plan view, and you can see that this is starting to look like a key plan. Now, even at this point, I could actually extract that drawing out. I could also get the volumes for that floor if I want to. But what we're actually doing underneath this is that we are actually creating a 3D model. Okay, so you can see here that I've been working in 2D, but this has helped generate a 3D model. Okay, and in here I can come and look at things both in 3D as well as in plan. So simultaneously you can work in plan and 3D. If you've got other screens, you can pull views off. Okay, so if you're working with a couple of screens just to make things easy, you can take advantage of that as well. I'm now going to start to put in things like my brickwork loading. In here I can come and edit, say, beam wall loads. You can come and choose from libraries here of standard brickwork finishes, okay, or you can build them up yourself. And then you can just type in properties, and then I've just then come and quickly created loading on that beam. Now, things like beam loads can be copied easily. Okay, we can just come and select elements around the periphery here. Okay, so you can see I'm just working my way around the edge of the building, and we can copy and paste those. So you can see that loading has just been automatically assigned to the perimeter of the building. Okay, now remember that we are working with a physical model. So if you want to come and place other things within the model, maybe you have some openings for things like services that you want to place, you can just come and easily create those. Now these are objects, so I can pick them up and move them around. So if I made a mistake with the positioning, I can just reposition these, and that's instantly updated. Okay, if you have other things going on in the building, perhaps I want to introduce drops and the like, these can be easily defined in here. So maybe I've got a bathroom, and maybe I've got a set down to the slab that I want to look at. We can just create that drop, and you can see that part of the slab has now dropped. You may have other things happening in the model. Perhaps you've got some additional loads that you want to define. It could be a brick wall load, for example. Maybe you want it to sit directly on top of a slab. Maybe it's a partition or something. You can just come and create that. And again, anything that you create in here, whether it's line loads, point loads, patch loads, all this will be visualized. You'll be able to see exactly what's going on within the model. I might also, at this point, just take the opportunity to maybe introduce some openings into the wall. Maybe I've got some, maybe in my shear wall there, I've got an opening for a window, or it could be a door. You could have multiple openings. You can just come in easily in here and create that within the model. Now that just gives you an idea about how you might go about creating a key plan. Okay, Now there are some other smart things that we can do with this. So if you have other types of geometry going on, other types of elements that you have within the model that you're wanting to consider, and what I'm talking about here is maybe irregular elements, then these can also be worked within the model. So an example here might be that I've got maybe an irregular column. It could be, say, a polyline column where I'm wanting to create unusual geometry. So in here, we also have tools to allow you to work with this. So if I have maybe a column shape that's a little bit different, okay, I can come in and create this element and use that back in the model. Now what we can also do is use this to help us drive our detailing and set out. So we will pick up automatically regular shapes and we will provide detailing for those, but we also have the ability to be able to create detailing for any type of geometry that you might have. Now I'm just going to come in and ask it to try and automatically contain this, and you see it's found the perimeter there and it's placed some bars and links. I can also work with this. So if I want to add an extra bars in here, maybe I want to add an extra couple of links to tie things together, or maybe I want to create some links around the edge there as well, I can. If I wanted to add extra bars in here, okay, we can also work with this just to create this as what we would call a template to then be used for the design and detailing. So I'm going to put some extra sidebars in there, okay, maybe my spacing needs to satisfy the code, and I can come and create whatever type of rebar arrangement I like there. Okay, so you can use this tool to virtually create any type of shape, any type of column geometry that you like. And once you're happy with that, you can just hit OK, and that's then returned to the model. Now, similarly, we can do similar things with the core wall here. So I'm just going to come and grab the core wall, and I'm going to get the software to merge this. So this is now merged, and if I go back to our little polyline column editor, the merged wall is now available here. Now in here, there are tools that allow you to create any type of configurations you like. You can introduce end zones. You can work with the bar arrangements to provide exactly the type of detailing you want. I'm just going to ask it to automatically contain this, and if I just hit OK, you can see it's come up with a detailing arrangement. So this allows us to then detail around things like corners. Okay, it also allows us to design this wall system as a single panel. Okay, and we can then design and detail that as one object, and it's treated as one object within the design of the software. So maybe I'm happy with that. Then at this point in time, I may want to start to look at elevating this model. So let's just come in and insert a few stories. Let's make this 5 stories high, and hit OK. And then you can see that that's put in placeholders for those 5 stories. Now I'm going to start to generate information up. So I can choose the first story, and I can copy this up. Now you can choose what you want to replicate up the building. Okay, it's very you can choose anything. So it could just be the columns that you want to repeat up. Maybe it's just part of the building. You can just select that and generate that up multiple floors. Maybe have different arrangements in different parts of the structure that can be created here. So if I hit OK, you can see that that's just generated up those that part of the floor. Okay, and you can see there that we've come in and starting to define what might be a complete building. Now you can work with this. You can make changes as you go. So if I want to remove things out, I can. If I'd like to come in here and maybe filter things out, I could also do that as well. So perhaps I'd just like to filter a few beams. Okay, and maybe I just want to come and grab all the members in the roof here. Now what I'm going to do at this point is I'm just going to remove those, and instantly I'm then left with, say, a flat slab system. Okay, now you can make changes in here as well. I might decide that instead of having my wall there, I'm going to remove that, and maybe I'd like to come in and change this, and let's put in a column. Now I'm going to make, as it's a flat slab, I might want to introduce a drop head panel. Okay, let's put in a panel for the slab here. Let's make it 1500 square, and I can make a thickening just locally for the column to provide that. So I can then come in and place these columns within the model, and you can see that I've now updated our building now so that I've got my flat slab together with my drop head panels for the roof, but the rest of the structure may be a conventional building. So you can mix and match different structural systems in here. You can just adapt the model to suit what it is that you're wanting to achieve. Now I'm going to move to the roof now, and at this point I'm going to come in and create some steelwork. Now you can see just to the central of the screen there, I've got different steel icons that I can work with. Let's just grab a column. I'm going to choose maybe a UC section. You've got different libraries here from around the world. I think everything that's readily available across the world is in the library. If there's you can create your own custom sections as well to feed this. I'm just going to grab maybe I'm going to use a British section, for example. Maybe we choose a certain column, and then I can work with that in the model. So you can see here that I'm just creating these elements in 3D, okay, and I've just placed some columns there within my model. I wish to create some trusses, so to do that you don't need to key the coordinates in, and you can just come and select between elements here, and it will move you into the truss generator. Now this is very flexible. You can have different types of trusses. Okay, in fact, it's really flexible. There's a wide range of different truss systems that we support now. Okay, and you can come and choose to the way that you might like a truss to be created. Now you can play with this. Maybe I want to have 4 bays or spans instead of 3. You can just adapt this to suit. Okay, member geometries are set up here, and you can come and play with these. So maybe you want to have for your internals, maybe you want to have an angle, or maybe you want a tubular section, or perhaps you want maybe you'd like to use a channel. It's up to you. You can just come and manipulate with this. You can play and reorientate things to suit. Okay, and then you can just adapt this to suit. So here I can just come in and make these changes to the model. Okay, and then they're done. Now you can position things like splices if you then want to move into ProtaSteel later and design these. So if I just said okay, that's created. The truss then becomes available to use elsewhere. So we've got just smart copying features where I can just grab that and we can just place this across the top of the building there. Okay. Now, I may at this point also want to work with some steel beams. Let's just come in and create some steel members. I'm just going to choose a section. Okay, I can control fixities here. So if I want to pin both ends of the member, or maybe pin one end or pin the other end, you can see in the properties dialog you can control this, and then you can just come and place it. Now it understands that the columns exist, so those beams will be automatically split. Okay, I'm just running across the top here, and you can see I'm just placing those members as I like. Now if I come to the roof, then I can just come and place members in the roof. Okay, you can see I'm just quickly doing that. There's intelligent snap points, so if you have unusual geometries, you can just snap to appropriate points within the model to make those connections. The final couple of things I'm going to do in this model is I know that working with purlins can also be a bit tedious, so in here you can also drive the arrangement of purlins in here. So there's purlin generators here. We've used the truss nodal points as a set out. You can change these, so you can key in your own arrangements here. Okay, I'm going to come in and maybe choose a slightly bigger channel. Okay, to start with. Okay, that can be set. Okay, you'll also maybe notice that we've also provided you with the sag rods here. So this is an update that we've introduced in the software recently. If you don't want to consider sag rods, this will help with the economy of the purlin design. But if you don't want to have them in there, you can also remove these. Okay. Now the purlins can also be used to restrain the truss, and this will help with the effective length calculations for the truss. Okay, and buckling length considerations. You can also take advantage of that if you wish. Now you can also apply additional loading here to the purlins to set this up. But if you're just happy with that, you can hit OK, and then those purlins then get created. Now let's brace the building, because obviously I don't want this to fall over. So we can just choose a couple of elements. I've chosen those 2 columns, and then the software will propose to me a bracing arrangement. Now you can have different types of braces, V braces, K braces. Maybe you've just got a typical diagonal. It's entirely up to you. You can come and choose different sections in here. Maybe you want to use maybe a tubular section, for example. Okay, you could come and choose something appropriate, and then this will adapt. Now you can see here that those are crossing each other at the moment. I may want to just join them. It's entirely up to you. You can play with all the orientation of everything in here. So if I wanted to move a brace by say 500, you can see that I've moved that, Now the analytical wire has stayed where it's put, where it is at present, but if I want to realign that, I can. Okay, so it's up to you. You can adapt things. We're not necessarily changing the underlying analysis considerations. It's entirely up to you, but you can just work with this to achieve what you want. And you can preview what you're going to create before you create it. So let's hit OK. That gets done. Let's come across the top of the building here. I'm going to just create a bracing in that plane as well. Let's hit OK. Okay, and we can just work our way across to create the bracing of that particular part of the building. Final thing I'm going to work with here is, let's just put in some girts. Now I'm just going to choose the peripheral columns there. You can play with the spacing, so let's just say it's 650. Again, I've got my sag rods in there. I might just take those out just for efficiency. And if I hit OK, then they get created also. Let's just work with this again, one more. Okay, and then OK. So very quickly there, I've just come and set up a simple frame. I could put the girts across the front if I want. I could introduce wind posts. It's entirely up to me what I want to create here, but I'm just trying to give you an idea. Now, the important thing with what we're creating here is that this is a physical model. So we're setting out everything physically. And this is very important because it then allows us to drive both the design and the detailing. Okay, so what we're creating here is what you would get on site. So you can see that the purlins there are sitting on top of the truss. The girts are on the face of the column. The bracing's in the plane of the column. Okay, the concrete structure is set out exactly how you might see it constructed at the end of the day. So this is how we work with physical objects. It's a structural BIM design model. So we're actually creating real intelligent physical objects that we then can drive through the analysis and design process. So we've completed a basic model. I now want to move in to look at the analysis and design processes. So I'm going to come in and just show you how this works. When you come into the system, you can come and choose your preferred codes of practice. Okay, so within the software, if you're wanting to use American codes, British standards, Hong Kong standards, Euro codes, we also have Turkish standards being headquartered in Turkey. And there are other international codes that we're progressively introducing in here. If you are working and locally, there's also variations for local standards. So if you are tuning in from, say, Indonesia or the Philippines, there'll be localized codes are there for Seismic, as well as standard IBC, UBC, and Eurocode standards are available. Okay? But as I mentioned, we are continually adding new standards, and we've got some new standards on the way that are coming in very shortly that we will announce with the next release of the software. So in here, I'm using the Eurocode. I'm using it to the Malaysian National Annex. And if I just close that down, we then will cover parameters to that local National Annex. So here in Malaysia, you can come and choose your preferred city. If you're working with the generic Eurocode, then you'd have the generic options here. But for each country, we've come in and localized this to suit their local requirements. So in Malaysia, for example, there's various seismic maps that you can choose data from. But if you don't have these maps available, or maybe you're not, you're in different countries and you want to use Eurocode, then you can choose the generic EC8 option, and then you'll have full access to the EC8 code, and then you can just key the local parameters in accordingly. So we will then adapt this to suit. You can choose from different ductility levels. The software is very capable and very powerful in performing seismic design. So if you are in a highly seismic region, we have significant capabilities in this area to really help you deliver design and detailing to suit what are quite tedious and can be very time-consuming design requirements to meet those requirements. So you can work with high ductility or medium ductility frames, or in this case, I might just work with a low ductile structure. Okay, things like importance factors and so on can be prescribed depending on the type of structure it is. We will work with ground conditions, and if you see that if I change the ground conditions here, the spectral curve will adapt to suit the code-based requirements. Now, if you do have a spectral curve of your own, you can import this. You can bring it in Excel and load that in here. So this can be fully customized to suit where you may be in the world. Seismic loading is applied eccentrically. Okay, you can choose a number of modes that you wish to consider in the analysis. If you're running a response spectral analysis, dampening and so on can be adjusted to suit. We have some quite sophisticated checks that we can perform for irregularities. These are very onerous and are a requirement if you are in high seismic zone. So if you're designing a building in the Philippines or Indonesia or maybe Turkey, these would be key requirements that you need to meet. So these are automated within the software, and we will check things and we will apply penalties accordingly if they are required. So things like torsional regularity checks, mass and stiffness checks and plan, all these types of requirements will be looked at as part of that process. There are also some quite advanced design capabilities. So for seismic, we also check for joint shear, strong column, weak beam, action, and there are a number of other key things that we do to make your life easy. So we will automatically scale base shear against the RSA result, the RSA results against the base shear to give you correct values, things like this that maybe normally you'd have to do manually. So I've had OK, that's set up. I'm now going to come in and create my loading. Now you can come and define your load combinations here, basic dead load, pattern load. Stage construction cases can be set here, okay, and electrical cases can be set up here as well. So seismic cases, notional loading, okay, or wind loading cases, all these can be defined here, okay, and you can just set these up to suit. So if I did choose wind loading and notional horizontal loads, then it will then develop all the load combinations here for me automatically. So these are all set up in accordance with the code. Okay, they are adaptable, so you can just come back and make changes if you decided that you didn't want to consider certain things in here. Then you can just adapt these to suit. It's entirely up to you. Okay. So now I'm going to come and also I can come and adapt the parameters to suit the way I'm doing my design. So if I have certain bar sizes that I wish to omit and not consider in the design and detailing, I can do that here. Or if I have different grades of steel and concrete that I want to use, all these can be specified at this point. Okay, so they can easily be set up. Now I'm going to run the model. We can have different crack section properties for lateral cases. So if you are following the American code, there will be certain stiffness adjustments. You can make these adjustments to the Euro code as well if you wish, but sometimes for lateral cases, particularly for seismic, you may be considering crack cases, but then you don't want to use crack cases for gravity cases to say the Euro code. You can look at both of these concurrently. So I can set up two different stiffness matrices. One is cracked section properties for lateral cases, perhaps, and another one is uncracked for gravity cases. And we will run these concurrently, and we can envelope these for design. I'm going to use rigid zones, and the reason why I want to employ rigid zones is I want to maybe drive a little bit of economy. So instead of us taking moments at center line, we build rigid arms out to properly represent the size of the beam column joints, and then we can then use those for more efficient design. If you had your foundations in the model, after the first run, I could produce a preliminary design. We can merge those back into the model, and we can look at soil structure interaction here. Now I'm going to mesh my walls, and you can play with the meshing parameters here. I'm also going to come in and mesh a slab. So I set up at the fourth floor there, I have a mesh slab. So I'm going to define that as being meshed. Okay, and I can play with the meshing parameters here, as well as in plane stiffnesses. Okay, so these can be set according to your preferences. Now the analysis is a button, and what we can do is once we've got this in place, we can then just move in and ask the building to, we can then just come in and run the analysis and design. And you may see pre-analysis that there are building model checks here that you can perform. Okay, these will just interrogate the model and make sure that you haven't made any silly mistakes with the way that you've gone about creating the model. If you're an existing user, I would really encourage you do this. It will highlight to you, maybe you've made some errors with connectivity, that type of thing. They'll be picked up as part of that process. So that's a great tool just to use to make sure that you haven't made any silly errors before you get into running the analysis. Now with this Service Pack 7 and with Service Pack 6, we've introduced a new 64-bit solver. Okay, we've enhanced the speed significantly over previous solvers. Okay, and this also allows us to, has allowed us to cater for significantly larger projects and models. We see some very, very large buildings, 40, 50 story high buildings coming all the time, and we've enhanced the system to be able to cater for those types of projects. Now the program also will check things as it goes, so it knows that I've actually got a couple of columns that are sitting on top of the transfer slab. You might recall I've got the steel sort of shed sitting on top of the roof there. Okay, it's picked that up and it's asking me if that's what I want, and so it will check things as we go and highlight things to you as it works its way through. So now it's moving in and running the analysis, and you can see it's just going through and preparing the data. Okay, we've compressed significantly the amount of time that this takes with the recent builds, and the analysis is done, and it's now doing a lot of the post-analysis checks. So these are the seismic checks that I was talking about with looking at irregularities. We will also check to make sure that things like loads are being chased down properly. For users, you might have just seen that maybe I would like to use an FE load distribution because of the way I've modeled my slabs with extra loads. Now you can also see a summary of the irregularity checks that we've performed to the seismic code. If something's not right there, then that will also be highlighted to you. Okay. So now we're done, that's closed. It now moves in and will then move in and automate the design here. So I'm now moving in and designing all my columns, beams, walls. I can also design steelwork in a batch process. Okay, and we are optimizing things as we go here. So it's going in and trying to select the optimum arrangement of bars as we progress through the design. So we've designed all the columns and walls, and now it's moving in to the beams. Now what you may also note, and this is probably not a feature that even our existing users probably use as well as they could, is that there's check design features there. So whatever you design in the system, we keep. So once you've done your initial design, you may find within a project that there are changes that are occurring. Maybe some additional load gets added to the building. Maybe I've got to change some of the structural configurations. The idea with this platform is that you just make those changes, and those updates are automatically can automatically be checked against the existing design that you've performed. So anything that doesn't pass because of those checks will then be highlighted to you. So it's a really nice tool for being able to manage changes, the inevitable changes that occur on a project. So we're done. I'm going to come in now and look at the analysis, post-processing. We've introduced the new, this is just a little, I guess in a way, a preview of what's coming with the 2020 release, a new analysis post-processor. So I'm going to load this and show you the model results. So think of this a little bit like you might see in SAP or STAD or any other general analysis program. You can come in and start to interrogate results. So from that physical model, we've automatically created the underlying analytical model, and we've performed the analysis. So in here, you can come and look at different results. You might be interested in looking at, say, axial loads. If you come in here, you can see how the axial loads are increasing or decreasing as we go up the column, increasing as you go down. You can filter out, so in here you can just adapt this to suit what it is that you want to see. Maybe I'm interested to look at shear diagrams, or perhaps I'm interested to look at bending. Now earlier I was telling you that I've used rigid zones, and you can see that we've built rigid arms out automatically in the beam column joints. So that allows us to take moments at the face and not center line. So this will help drive additional economy in your design. Okay, we'll take advantage of that, and often you can see a small saving in the reinforcement that you might otherwise need to provide. Okay. Now, if I'm interested to, maybe I'd like to go back and look at the whole model, and maybe I just want to filter out. Perhaps I'm interested in to see how it's performing under seismic, and I would like to see the behavior of the building under lateral loads. So you can see here that instantly we're rendering this, and instantly you can see how that's behaving. Okay, I might be interested in looking at the modal behavior. Okay, my first mode is not ideal, it's a torsional mode there. I've got quite an eccentric structure, but you can see higher mode shapes here. okay, the fundamental period and the X and Y directions, and we can look at higher mode shapes here. So you can look at the various dynamics going on within the building. Okay, so you can see that behaviour here is all animated instantly. Okay. So if existing users would have seen a significant performance gain there over our previous post-processor. So this just allows you to get in and access information extremely rapidly. So if I'm happy with that, we can now move in to look at the design. You can see here that I've designed all of our columns. If you just click on a particular column, you can look at this in more detail. You can see what's critical in terms of design. The interactive design is here. What we do is we calculate the neutral axis there, and we work out the lever arms away from that axis to work out capacities. Now, detailed design reports are created, and you can review these here as well. Okay. I also can come and look at things like interaction diagrams. They're available here as well, so you can easily see the results. Okay. Similarly, if we come to beam, we can come and look at the beam design and the model. Okay, I'll just open these up and click on a member, and we can interrogate this in more detail. Okay, so we've optimized the selection of the bars here. Okay, I can look at the diagrams in here, and you can see that there's diagrams here which summarize the envelopes. You can look at individual cases here. So the envelope there is a build-up of all the different combinations to create that one envelope here. Okay, so you can see that envelope. If you want to look at other things, maybe you're interested in displacement of the member under gravity. Okay, you could come in and choose that, and you can look at different types of relative displacement, normalized displacement, or absolute displacement. So you can come and choose different views here. These diagrams are dynamic. You can just zoom in and out to interrogate the results and see what happens. So maybe I'm interested to know if there's any torsion in the member. I could show that as well. If I want to turn these on and off, I can just adapt the views to suit what I want to view as part of interrogating the results. Okay. Now, now this design is live. Okay. When you come in here, you can adapt things. So if I reduce the number of bars there, you can see that this is no longer satisfying the code, both spacing requirements as well as the amount of steel. So you can work with this and you can adapt these results to suit. Okay, but this is we're doing this on the fly, and it's checking things to ensure that they comply with the code requirements. Now I'm just going to come in and just show you a couple more things. I know that we're kind of maybe going over a little bit on time, but I'm just going to come in and show a few more things here, and then I'm going to get into the documentation. So I'm going to let me grab some, come down to the foundation level here, and I'm just going to grab those external columns. And I have options here to insert pad bases or pile caps. So in here we can define, and under our foundation settings, we can set up allowable working loads and so on, but the system can then automatically design our foundations in a batch process. I'm going to group these, so it will find elements which are similar, and they'll be grouped in the model, and you can then see that I've now designed my pile caps in a batch process, and they've all been rationalized and placed within the model. Similarly, if I have a pad base, again, we could come in and create this in here. You can key in basic parameters here. Okay, and the column data, all the loading has come down. We'll then calculate this. It will work out what's required. Maybe I want it to be a square footing. Maybe I want it to be slightly eccentric, perhaps on the boundary. So you can just come and adapt this to suit. It's up to you. You can just create this until you're happy and it's designed. Okay, and then you can create that. Now there are a range of different foundation systems in here. We just don't stop at pad bases and pile caps. You can come in here and define things like raft foundations if you wish. You can keep parameters in here and create those. Maybe I'll just make that up. And you can also cut strips through these. You can do integral strips, finite element analysis for the design. We will also perform punching shear checks. If you found that wasn't adequate, you even have the ability to be able to come in here and insert piles perhaps wherever you want them to be. So if I've got an arrangement of piles beneath the raft here that I'd like to generate, I can come in and choose those, and you can see that it's established a arrangement there. Now all these are editable. You can place additional piles if you wish. If you don't want piles, you can remove them out. all this is adaptable to suit the project that you're working with. Now, there are other foundation systems. There are strip footings, combined foundations where you can merge pile caps, pad bases together. Okay, so there's a very broad range of different foundations that you can apply into the model here. Now, at this point in time, I'm going to move in and just create some documentation. So I'm going to come and create start to now publish out some drawings from this model. Okay, and to do that, I'm going to load ProtaDetails, and ProtaDetails is our system for automatically creating all of our general arrangement and concrete details. Okay, and it's just going to load this. You'll see it just pop up in a second as we load the project into ProtaDetails, and we can then use that to start to create that information. Now, ProtaDetails, as I mentioned earlier, is also a complete CAD system, so you can happily draft in ProtaDetails and create additional details as you go. So it's a DWG file format. The commands are very similar to AutoCAD, and you can work in here. Maybe you prefer it. Perhaps it might be an alternative to using, say, AutoCAD or other CAD platforms. So I'm now in here. I'm just going to ask it to automatically create. Now I can choose what I want to draw here, and you can insert these to a sheet. Now you can come and choose your own title block here, and you can make labels here. So if I want to call this, say, key plans, and I want to reference the drawing as, say, KP, KP1, KP2 and the like, I can do that. Okay, you can make other adjustments here, so you can play with things like scales. Maybe I want to play with the way my beams are truncated within the drawing sheets. All this can be set up here. And once you're happy at this point, you can then just come and draw. So I'm just going to create the drawing, and it's going to go away now and lay things into my sheet. Okay, and what you might see there is it's just started that process. It's laid out our sheets, and it's now going to go through and progressively start to detail things out. So it's trying to optimize the placement into the sheets here for you. Okay, it's looking at coming up with the best arrangements that it can. You can, of course, work with the details post creation and move things around and adjust it to suit. Okay, you might just see there that I've got the key plan in there. You can see the foundation drawings, arrangement of pile caps and so on is provided. All the dimensioning and so on is all done. Okay. Now it's just adding a few more beams, and we are done. Now if I zoom out here, you'll see that within one shot we've actually created all the drawing details there. So you can see that all these sheets are created instantly. You don't need to do this. You can just draw out the individual elements. So you might just want to draw out your beams first, then your columns, and so on. It's entirely up to you how you approach this. We wouldn't recommend for a large building that you do dump it in one go, because this is a CAD file and this file can get huge. Okay, so you may just want to look at breaking them systematically into different sheet files. So if I come in here, you can see our key plans. Okay, foundation drawings, our key plans. The detailing is intelligent, so it knows that this is the edge of the building. You can see that things like the dotted line creations are all automatically done. All the slab referencing is provided. It's very flexible, so you can adapt this to suit. Here you can see our key plans, okay, and we've laid them into title sheets, and all the proper referencing is done. As I mentioned, that's adaptable. Now there are different drawings depending on what you want to show. So if you'd like to see set out against grid, you can provide this, okay, and you can also see the shear walls and so on drawn within there. You can also provide your elevation. So here I'm showing an elevation of the shear wall, and you can see the opening we've also detailed out for that opening as well. Okay, we've also done the detailing around the core walls, so you can see how this is set out. Again, as I mentioned, this is adaptable. With this particular wall, the steel percentages are very low, so it's omitted the ties. If you want to include the ties in the wall, you can. Okay, there's a lot of different settings within here which you can control with the way information is presented. For seismic regions, you would typically draw columns and elevation, and because you'll have varying link spacings. You can play with the way in which things like laps are set up. If I want to lap at mid-height, for example, that could be set up. And we would recommend that if you are in seismic regions, that you do detail elevations, because they will make it very clear as to how the column is constructed, and the end zones or the capacity detailing would be clearly shown. But you don't need to do that. You can also have things drawn into plans. Okay, and here you can see some sections here. Now we're automatically grouping all the columns together, okay, and they'll be automatically grouped by the system. Everything that's similar will be grouped, and so you can quickly rationalize the way in which the things are designed and detailed there. So even my irregular column that I created before, we've designed and created the details for that as well. Now, if I come down to the beams here, you'll just notice that well, you can just come and notice the elevations here. Like all the laps and lengths and so on are all being detailed out there. Okay, if you just notice in the detail, there's 3 H20s, it's positional mark 8. So if I come across to the table here, you'll notice for 8s, there's 20s, there's 3 of them, 10.4 meters long, 31.2 meters in total. And here you can see the bar bending schedule. So we're actually creating all the detailed information there from that model. So everything is being quantified right down to lengths, laps, everything. So for this particular plan, there's 1,444.8 kilograms of steel. You can use this to compare different schemes. You can come up with the most optimal arrangement to suit the client. Now these are objects. So if I click on this, okay, you'll notice that this is the different diameters here. You can come and choose to adapt these as well. So if I didn't want a 20, maybe I wanted to change this to a 25, you can. Now this is a physical object. We actually understand much of the properties behind this, so the spacing, the cover, okay, how many there are, even things like lap distances and so on is understood by this. So you can see here that I've just made that change, and this is updated to 3 H25s. If I come back to the sheet here, you'll see that it's updated the size there, and it's recalculated the tonnage. So we actually got about 40 kilograms more because of that, 40 odd kilograms more because of that change. Now, if you don't want to show things draw all the details out, you can show things in schedules. So here you can see a typical rebar schedule. That might be your first port of call. Maybe you're doing an initial tender and you just want to provide some preliminary information. You might mix and match on a job. You may do some detail out some elements and just provide a schedule for the others. So the choice is yours, and here that information is available. Now in here you can also play with the details. As I mentioned, you are in CAD, so if I want to pick up elements, move them around, reposition them, it's entirely up to me. I can work with this just to create what it is that I like. If I want to do things like cut and chop and place, then all of this can be done as well, and I can just reposition things within the model to suit. Okay, so there's some really nice tools in here that can help you with performing your detailing. We also obviously have created all the pad foundations as well as the pile caps. They've all been created and they're all quantified here as well. Now, I can go and create additional drawings. Anything that I drew up in there before is actually available in here. So if I wanted to draw maybe a particular column elevation up the building, I want to draw the entire elevation, I can. If I wanted to just grab out a particular beam detail, anything that we've created in the model can be drawn out by itself as well. So you can just take advantage of that. As I mentioned, it is a CAD system, so you can do drawing in here. If you want to enhance your details by providing objects within here, you can. So this is entirely up to you, and you may want to place some rebar into that. Maybe it's additional pad footing detail, for example. You could come and work with these intelligent rebars in the model, and that could be created. Now, if this was a variation, I can select these elements and these can be instantly quantified. So because we're working with objects within the drafting environment, I know that there's 428.3 kilograms of steel there. If I was advising the client on perhaps a variation, this information is available. Instantly we can grab it, and it's all easy because it's all within intelligent object drafting environment. Now, I'm going to be about another 15 minutes. I just want to show you a couple more things in here, and then I'm going to move in and talk about Prota Steel very briefly. And I'm also going to update our users on some of the key functionality that we've introduced in recent service packs. So within here, there's also libraries of different component design that you can use. Okay, we have things like stair design, things like retaining wall design. All of these you can come in and choose. You can key in basic parameters here. We will design these and we will produce all the checks for these designs, and then you can create your drawings. So in here, you can just use this to come and create and design various components within the model. So it could be some staircases, for example. Maybe you want to design a retaining wall. Okay, you can key the parameters in here. I might want to introduce a shear key. Okay, perhaps I've got things like sloping backfill. These can just be provided within the model. We will automatically look at things like slip circle analysis. We will design this. It will do all the underlying checks. Okay, we can produce all the detailed documentation, and I will show you the report. Okay, this just gives you a sense of the type of output that we provide as part of the calculations that come with the system. So all the documentation is provided, and you can see detailed reports. So here's a retaining wall report. You can customize this with your own logo, and it's providing you with all the step-by-step calculations so that you can be confident in the design. Now, once you've done this, again, we can just come in and prepare the drawing here. So I can just come and create a retaining wall detail, and you can see those there. Okay. If you wanted to, you can carry on. You could include a sheet here. Okay. You can add in your own title block. Okay. You can insert this, and then you can just position those details in your sheet to suit. So again, you've got tools in here just to help you. Okay, I'll turn off the to place information within the sheets to suit your drawing output. Okay. Now that just gives you an idea. There are other calculations within the library. I'd encourage you to check out the pile design if you're wanting to come up with preliminary design based on SPT data for your site. That's a great calculation. If you just want to check a pile cap, maybe you've got eccentric pile cap arrangements that you need to check, then you can take advantage of using the pile cap in here as well. And there's other things like corbels and scaffolding and so on. Now what we also have is a detail library. So not only do we have the design library, we have a detail library, and these will cover things that you might want to quickly detail out. So if I wanted to create, so a culvert, for example, with a couple of channels, okay, in here, we can just use this, and you can specify different parameters here, and at the end, it will then create the drawing. So if you are wanting to create, say, a culvert detail very quickly, there's tools in here just to help you draft these up, and these can save you significant amounts of time providing that detail. Okay, so that's Prota Details. It automatically lays things into your sheets as I've shown you. It will automatically, you can work with these details, make changes. It's a drafting system, and you also have the advantage of having a library of various component design and detailing available to you. Now at this point, I'm just going to pop into ProtaSteel, and I'm just going to work with some of the steel detailing here. Okay, I did have another model plan, but I think given time, I'm just going to show you a very simple model, this model here in particular, and I'll work with this just to show you the essence of what we do with ProtaSteel. So I'm in the ProtaSteel environment. Now what we've done is we've communicated all the load combinations from ProtaStructure into ProtaSteel. So all the underlying analysis results are available in here. And what we do then is make use of this and make use of the physical model to drive the connection design and detailing. And if you notice along the top here, you'll see that there's a whole lot of different macros that we have here for performing different types of connections. So whether it's a fin plate or an end plate, or maybe you've got welded joints, or perhaps you've got a haunch, or various gusset plate configurations, you can use these macros to help drive the detailing. And it goes right down to even looking at connections to maybe concrete, okay, or even things like embedded anchors, right down to things like checker plate and handrails and so on, can all be created in here. So the idea is that you do the basic modeling and design inside of ProtaStructure. You then pass this in to ProtaSteel to finish off the connections, provide the connections, and then finish off all the detailing. So I'm just going to come in and work with this. I'm just going to come and create some quick details. So the idea is you just choose a macro, and then you can apply that. So here you can see I've applied a simple connection to connect the purlin to the column. Okay, and I can just work across different elements here. Here, I might want to come in and connect my beam to my column. So I may want to choose, this example, an end plate connection. And we can come and just choose this, and you can see that this has been created there. Now, underneath this, as I mentioned to you, we're actually transferring all the analytical results. So I can come in here and I want to look at a connection report for that particular connection. So let's have a look at that to Eurocode. You can choose American codes, British standards are in. There's other standards that you can design that to, depending on what the head code that you've chosen. And here you can see that we've documented all this out. So you can see detailed information, step-by-step checking that we're performing to satisfy the codes of practice. So end plate checks, back plate checks, various checks in here that are used to satisfy the code, and all the detailed code score referencing is provided there for you. Okay, now if I had to go and do this for the whole project, you can imagine that that could take a significant amount of time if I had to click each time to create those elements. So what we've introduced into ProtaStructure is a system called IntelliConnect, and this has been enhanced significantly over recent service packs. And the idea is in here you can come and choose the type of connection that you want to create, and we will batch design them. So I'm going to maybe create my purlin connections. I can choose a preference here. Maybe it's a reversed angle cleat. I can play with things like maybe I'd like an extension to connect my cladding to. And if I just run that, you can see it's just now moving through and batch designing those connections all in one shot. So they're done. And if I come into the model here, you can see that we've created those connections there. Okay, I might want to carry on. Let's do some other connections. And maybe I'd like to create my girt connection. So again, I can come and choose a preference here. I can run that, and it's now going to go through and make those connections for the girts. Okay, so you can see the model there's updated, and you can see that my girt connections have been applied. Okay, now I'm going. If I just look at this here, this front frame, I'm going to come in and I want to design the truss. I'm going to ask it to design the internals on that truss. And if I just run it, we will automatically size up the gusset plates, but you can see it's just working across the truss there, and it's looking to design those connections as well as we go. Okay, so connection by connection, it's creating, it's looking at constructability as it does this, and it's trying to create and optimize a connection design there for you. Okay, so you can see there that we've made those connections here, okay, across the frame. Now I'm maybe in this situation here where we've got quite a difficult scenario to connect the top chord of the truss to the column. There's other elements in here that you can take advantage of. I'm going to use another connection macro that we've created to just deal with that very scenario. And you can see there that it's come and created this. Now, this is a macro, so you might just see that my bolt's piping out the top there. I'm actually able to work with this. These are intelligent macros, and you can make changes in here to adapt the connection to suit. So I might want to drop that a little bit. Maybe I also want to just adapt this to suit. And you can see I've just moved that down, and I've adapted the connection to provide what I'd like to see in terms of connection there. Okay, so these are intelligent macros that you can work with just to create what it is that you want to see. So you can fine tune things as you go. Now, last thing I'm going to do in here is just create a quick connection. So I'm going to use I'm going to create a truss connection. Let's just call this truss 1. We can add this, and I can select objects to form part of what I want to create with the documentation. So I can just choose the elements that I like to see within my detail. And what you'd see there, that when I've created this, I've created a box around this, and think of this a little bit like a camera, and I can choose different views that I'd like to see of that joint. So I can just come and choose those views in here from the model, okay, and then we can then use those views to help us generate our connection details. The final thing I'm going to show you to do this is that we can cut some views through this model. I'm going to choose a couple of points to do this. Okay, let's just come down here. We can cut a section across. Here you can see the elevation, and you can see the actual connection detail and what it might start to look like here. And I'm going to go to my drawings, and I'm going to create, in the drawing manager, I'm just going to create a sheet to place these into. So let's just call this, say, truss, and hit OK. I've got my title block available to me, and this view is being populated into the tree here. And I can just grab this and we can just place this within our sheet. So here you can see the connection, truss elevation there. At this point, I might want to just start to do some of my own annotation. So we can come in here and start to dimension things out here. Okay, so it's entirely up to you how you want to work with this, but you can start to dimension things. But what you'll also notice is that this connection, that box that we created here is highlighted to you. And if I just hit the box at the top there, it will then allow me to move in and create the connections. Now I'm just going to turn my weld annotations off. Okay, but here you can see that we've actually moved in here, and you can see that these connections are now being shown. And the truss is actually annotated, so you can see that TR1, okay, relates directly to this connection detail here. Now, once we're in here, we can work with this. So I can come and choose this connection detail, and we can annotate things. So if I wanted to maybe put the member properties in here, I may also want to assign the bolts. All this can be easily done. Now, these are dynamic labels, so you can move things around if you want to just adjust things accordingly. And you can also start to do things like dimension things out. So you can just come and dimension elements in here to suit what you want to show. So the idea here is that you can just come in and create your different views, sections, elevations of the model, and then you can automatically produce all your steelwork detailing from this. Okay, it's all very seamless. Now, if there are changes, this model will adapt, it will automatically update, and these views will all automatically update as well. So if you are making changes in design from ProtaStructure, those changes can be seamlessly populated back into ProtaSteel, and then the associated connection details or drawings that you've created can be updated. So that gives you an idea of ProtaSteel. Okay, I have not gone into other things that we can do in here. We can create things like shop drawings. We can create full material lists. It is a very powerful system. In fact, I'd say it's one of the most powerful systems available which is fully integrated for doing steelwork connection design and detailing in the industry globally. So if you are doing a lot of steelwork, then you may find this tool as a fantastic addition to your design and detailing library. Now, so I hope you've enjoyed that simple model. What I'm going to do now is I'm going to finish presenting, and I'm just going to go back and just cover some of what we've gone through today. And I'm also going to touch on some of the new things that we've introduced with this particular Service Pack 7 update. So what's new since Service Pack 4? Service Pack 4 was probably the major release that we've been in touch with in terms of webinars, but there's a lot. There's been a huge amount delivered over the last 3 months. One of the key things that we've introduced, particularly for seismic design, is performance-based assessment and design. And we've enhanced the different methodologies that we can create by also providing a non-linear analysis and design for pushover and time history with our integration with OpenSeas. Okay, now this uses a fiber model where we are using a distributed plasticity, and we're using that, we're developing that model inside ProtaStructure. We feed OpenSeas, it will then run the analysis, and we will do all the post-processing and all the associated checks. So for nonlinear static pushover, we will provide you with performance plots. Okay, these can be user monitored. You can choose different nodes within this. Any stage can be reviewed, and you'll get a performance assessment report that you can look at various aspects. Maybe you're looking at immediate occupancy or life safety. There's different reports that can be produced to help you with this. We also perform nonlinear time history. You can choose different ground motions. They can be run in different directions. Okay, we will automatically rotate those 90 degrees to satisfy code requirements, and we will automatically do the scaling. So if you're familiar with this, you'll know that the scaling of the various ground motions that you use is very tedious. ProtaStructure has some very powerful tools to help you automatically scale those so that you can match your design spectral curve that you're wanting to run. And again, we will produce reports that will look at the performance of the building under those scenarios. We've introduced new 64-bit architecture for analysis, and as I mentioned, this has had significant speed gains, and there's also a new analysis post-processor. I'm sure the users will really like this. Okay, everything is almost instantaneous. Okay, it's very fast and fluid. We've also improved performance enhancements for the modeling. So if you're working with large models, you'll see that this is significantly faster, very quick to work with large models, large floor plans. It's very, very easy to get around models now and adapt things to suit projects. Just a little saver, for some users will appreciate this. If you're working with wide transfer beams, we now automatically set up rigid arms to collect maybe different columns that may be sitting on different positions along that beam. All the torsional forces will be considered and designed for within the transfer element. So you don't need to worry about collecting those. You do need to make sure that you mark the column as a transfer in the column properties dialog. We've enhanced buckling length calculations significantly for steelwork, and purlins can now automatically provide restraint. Okay, it's very smart, effective length calculations, buckling length calculations for all steelwork. Okay, and this really drives economical design for the steel. There's new deflection checks that we've enhanced to cater directly to code element requirements. And these are also adaptable, so you can set your own preferences to suit different deflection criteria that you may have on a particular job. We've enhanced the range of different trusses you can have in the models. There's very comprehensive truss modeling. This has been continued to be enhanced. And we've also enhanced the way purlins can be modeled. So purlins can sit on top of trusses. They can also sit on bottom chords. It's very flexible now. You can create virtually any type of purlin configuration you wish. Prota Details has also been enhanced. We've got new retaining wall design and stability checks that have been introduced for that. This is of particular interest to those who are doing seismic design. You'll find those are welcome. We've enhanced our precision detailing. So for things like columns that are maybe sloping, sections that may be tapering in, all the detailing has been significantly improved, openings and the like with this release. Do have a look at the component design library. There's a real broad range of calculations in here that you can take advantage of, okay, and as well as the component detailing library. So things like continuous beam detailing, foundations, pad footings, lift pits, culverts and the like can be done. Now, Prota Steel, we've continued to work with. So in this service pack, there's new checker plate options. There's options for stairs and creating stair treads and so on. We've also provided handrails. So really, you can virtually complete any type of industrial structure using these options as well. So you can provide all the detailed output in terms of drawings, taking advantage of those. We've also been introducing or enhancing and providing additional design reports for almost all the connections now. So flange plate moment connection, beam column welded joints, simple base plate with stiffeners, moment haulage connections are all designed and fully documented with underlying design reports. And these join the many other connections that we have available within Prota Steel that are all being designed. We're now automatically dimensioning of key plans, so you'll see that they're all annotated with dimension lines. You can enhance these, you can provide additional dimensioning if you wish, and we're also providing all the leaders, as well as we're enhancing the annotation of standard connection details automatically for you. Okay, so if you're using the latest build, you'll see that those have been implemented. So for standard details and referencing, all this is automated within the software. Now, just remember too that obviously take advantage of IntelliConnect. It is automatically connecting everything for you. Okay, we do interrogate all these joints and try and come up with things that are constructible and workable. You can work with these. You can also create your own macros in here as well. So it's very sophisticated, but just jump in, have a go with it, and I think you'll find that it really can help you in a lot of situations with your steelwork. Now you can create intelligent presets and design overrides. So if you have preferences for certain sections with certain types of connections or certain pinned or fixed joint preferences, all these can be set. You can also have your own company standards, so you might have overrides for certain connections. Maybe you don't want two bolts in a joint, maybe the company standard is a minimum of 3. These types of things can be set up within the model. And obviously, all the underlying documentation is provided, all the detailed design reports. In this model, you can also see these are color-coded as well, so you can see at a glance if the connection's passed and satisfied all the code checks. And obviously, in providing all the both the detailed drawings as well as getting into shop detailing and providing all the fabrication drawings as well. Now, because it's a physical model, we can also communicate not just the ProtaStructure model, but also the ProtaSteel model with other platforms. So we can link it into Revit, Tekla, Allplan, etc. All these links are available through ProtaSteel as well as in ProtaStructure. We've also enhanced integration with Revit 2020, and that provides additional enhancements with the integration and round tripping, as well as some fixes. There's new IFC links available, and look, this is ongoing. We've got some really fantastic stuff coming that you can take advantage of as this unfolds. So just to conclude, obviously the system's being used increasingly globally by some very prominent businesses, as well as a multitude of small and medium-sized enterprises. It's being used on a range of really interesting projects around the world. Here's just some snapshots of those. In Malaysia here, we've got some very significant projects that have been done within the software. Even in London, software is being used on a range of different projects. Even King's Palaces are being used to design within the platform. Okay. Now, what we're trying to do at Prota is we're really trying to provide you with exceptional value. And this is why every system that we create comes complete. So it's not just about building design, it's also about drawing management, it's also about drafting, it's also about component design, quantities takeoff, all the different things that you may be required of a project we're wanting to deliver integrated into one system. And that goes right down to steel connections, right down to shop detailing, right through to collaborating this with other project parties. So this is what we're providing within one complete, integrated, seamless platform. Okay, and this is the vision that we have for the software, is to make it very intuitive and easy to use, all seamlessly linked, and all one platform that you can take advantage of. We hope you like what we've covered today. We are investing heavily in ongoing development of the platform. To our users, thank you very much for your continued support. It's been fantastic. We really appreciate the feedback that we get on using the software day to day. If you've got ongoing questions, if you want to get more out of the investment, please speak to us through our support channels. Please look at the help systems. I haven't done the knowledge base justice today. There's some fantastic videos, tutorials, and information on how you can get most out of the software. Please take advantage of that, and please keep in touch. We love hearing from you. It's fantastic. To those new to ProtaStructure, we do have some very special offers with the 2019 suite at present, and this is backed with direct technical support from us and our partners globally. Please email us at globalsales@protasoftware.com or asiasales@protasoftware.com if you want more information on that, or you can directly reach us through our website. We'd love to hear from you. If you've got questions on today's presentation as well, please feel free to drop us an email. That would be great. Do follow us. Look, we're online. We're on Facebook, we're on LinkedIn, Instagram, you name it, we're there. So please connect with us if you want to hear about some of the new innovations that we're making. And finally, I'd just like to thank you very much for your attendance today. I know many of us are in quite difficult circumstances, and I really value that you've been able to take the time with me today to hear what we've been up to. So on that note, I'm going to say goodbye. Thank you for today, and we look forward to being of continued support from you from now and into the future. Thank you very much, and Enjoy the rest of your day.